10th Standard Physics. Chapter 1, Laws of Motion. Today we are going to see about laws of motion. Laws of motion is the first chapter for 10th standard. Here first we are going to study about mechanics. Actually, mechanics is a branch of physics. It deals with the effect of force on bodies. This mechanics can be divided into two, that is statics and dynamics. The statics is a study which deals with the bodies which are at rest under the action of forces. Dynamics is a study of moving bodies under the action of forces. This dynamics is again divided into two, that is kinematics and kinetics. This kinetics deals with the motion of bodies without considering the cause of motion. This kinematics deals with the motion of bodies considering the cause of motion. This is the difference between these two, that is kinematics considers the cause of motion, but kinetics, without considering the cause of motion, it deals with the motion of bodies. So these are the definitions for kinematics, kinetics, statics and dynamics. Force and motion. Aristotle is a Greek philosopher and scientist. He said that the natural state of earthly bodies is rest. He proposed two types of motions. One is natural motion, the other one is violent motion. Natural motion is an independent motion and violent motion is a force dependent motion. If a force is needed, that is if a force that is a push or a pull is needed to make the bodies to move from their natural state, that is rest, and behave contrary to their own natural state, then the motion is called violent motion. If a moving body is naturally coming to rest without any external influence of force, then that motion is called natural motion. In this motion, a moving body comes naturally to rest without any external influence of force. So we can say this as a natural motion. Again, he said that when two different mass bodies are dropped from a height, the heavier body falls faster than the lighter one. Now we are going to see about Galileo's concepts about force, motion and inertia of bodies. The first point is the natural state of all earthly bodies is either the state of rest or the state of uniform motion. That is, in this point, he says that all earthly bodies continue in their state of rest or state of uniform motion. The second point is a body in motion will continue to be in the same state of motion as long as no external force is applied. The third point is when a force is applied on bodies, they resist any change in their state. This property of bodies is called inertia. That is, if you apply a force on bodies, they resist uh, to make any change in their state. That property we call it as inertia. When the fourth point is when a body is dropped from a height in vacuum, we can consider any number of bodies of different size, shape and mass. If we drop the bodies from a height in vacuum, what will happen? Actually, all the bodies of different size, shape and mass fall at the same rate and reach the ground at the same time. This is the fourth point. So we can once again see about these points. That is, the first point is the natural state of all earthly bodies is either the state of rest or the state of uniform motion. The second one is a body in motion will continue to be in the same state of motion as long as no external force is applied. The third point is when a force is applied on bodies, they resist any change in their state. This property of bodies is called inertia. The fourth point is when dropped from a height in vacuum, the bodies of different size, shape and mass fall at the same rate and reach the ground at the same time. Inertia. Inertia, in simple definition, we can say that inertia it's the ability of a body to maintain its state of rest or motion. In detail, when you say about inertia, you can say that it's the inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force. So this is a definition, the definition of inertia in detail. For example, we can say that imagine as if you are traveling in a bus or in a car. When a sudden brake is applied, what will happen? The upper part of your body will lean in the forward direction. This is because any body would like to continue to be in its state of rest or the state of motion. Similarly, if the vehicle you are traveling is at rest at the moment and if it is suddenly moved forward, what will happen? You will just go lean backward. This is because any body would like to continue to be in its state of rest or the state of motion. This property is called inertia. This is known as inertia. What is inertia? In a simple definition, you can say that it's the ability of a body to maintain its state of rest or motion. Then if you want to write inertia in detail, how will you write? It is the inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force. Okay. Here, an activity is given. For this, you need to take a glass tumbler and place a small cardboard on it. In the center of the cardboard, you place a coin. Okay. And after that, you just flick the cardboard quickly. What will happen? This cardboard falls off the ground and the coin will fall into the glass tumbler. What can you say from this activity? Actually, the inertia of the coin is in rest. That is, inertia of the coin keeps the coin in its state of rest when the cardboard moves. When the cardboard is moved, the coin falls into the tumbler because of gravity. This happens because of gravity. So, as a whole, we can say this happens due to this activity happens due to inertia of rest. This is because the coin is at rest. The coin falls into the tumbler due to gravity. Types of inertia. Inertia of rest, or the resistance of a body to change its state of rest, is called inertia of rest. Inertia of motion. The resistance of a body to change its state of motion is called inertia of motion. What is inertia of direction? The resistance of a body to change its direction of motion is called inertia of direction. Examples of inertia. First example, an athlete runs some distance before jumping because this will help him jump longer and higher. So we can say this type of inertia as inertia of motion. When you make a short turn while driving a car, you tend to lean sideways. That is inertia of direction. When you turn a car, what you will do? You will just turn to lean sideways. So this type of inertia is called inertia of direction. When you vigorously shake the branches of a tree, some of the leaves and fruits are detached and they fall down. This type of inertia is called inertia of rest because the leaves and fruits, they are at rest. When you shake it vigorously, what happens is the leaves and fruits fall to the ground. So this inertia is called, this type is called inertia of rest. Linear momentum. The impact of a force is more if the velocity and the mass of the body is more. To quantify the impact of a force exactly, a new physical quantity known as linear momentum is defined. The linear momentum measures the impact of a force on a body. The product of mass and velocity of a moving body gives the magnitude of linear momentum. It acts in the direction of the velocity of the object. Linear momentum is a vector quantity because it has both magnitude and direction. So, what's the formula for linear momentum? Linear momentum is equal to mass into velocity, that is P is equal to m into v. P stands for linear momentum and m for mass and v for velocity. The unit of momentum in SI system is kilogram meter per second and in CJ system its unit is gram centimeter per second. So what is a linear momentum? Actually it's a newly defined physical quantity. It's used to quantify the impact of a force exactly. So, linear momentum, it measures the impact of a force on a body. It's the product of mass and velocity. It's given by the formula P is equal to m into v. M stands for mass and v for velocity. Its unit in SI system is kilogram meter per second and in CJ system its unit is gram centimeter per second. Thank you viewers for watching. Like and subscribe my channel for more videos. Thank you.